We're going to net 5 and 5, we'll look at more trigonometric graphs and we'll look at phase angles. So basically the graph, we're going to look at the sine graph and it's going to either move to the left or the right. Right, we should all know what the sine graph looks like by now. I have plotted a table of values at the top, so let's just plot each one. So the first one is 0 along, 0 up, so it goes here. Next one is 45 along and 0.7. Now 0.7 has been rounded, it's really root 2 over 2, but I've just rounded it. So there's 90, so 45 is there, it's roughly about 0.7 up. And then 90 along 1 up, 90 along 1 up, 135 along 0.7 up, so it's in the middle of 90 and 180. 180 along, and obviously that's on the x-axis, so 0 along. And once again, I've not labelled my x and my y-axis. Then we've got 225 along negative, 225 is in the middle there, and negative 0.7. 270 negative 1. 315 negative 0.7. 360, which is on the x-axis, and 0. So there is your sine graph. So I'm just going to show you what happens here. So you can see here I've got y equals sine bracket x add 45. So if your x was 0, so if I put 0 in there, 0 add 45 is 45. So you're really finding sine 45. We already know the answer from that from the table above. So sine 45 is 0.7. Okay, next one. If x was now 45, so 45 in here again. The x is 45 add 45 is 90, so we're really finding sine of 90, which again we know from that top table of values, which is 1. Can you see anything happening here? Do one more. So when x is 90, again plug it in here. 90 add 45 is 135, which again we already know the answer to, which is 0.7. Okay, so it looks like this one has just it's going to repeat all of this here that I'm underlining from that first table of values. It has not included this one in the second table of values, so I'm just going to copy everything in now, and then I'm going to show you what that looks like. 360 add 45 is going to be out of my range, so I'm going to leave that just now. So let's plot these numbers here. So 0 along 0.7 up, next one 45 along 1 up, 90 along 0.7, 135 0, 180 along negative 0.7, 225 1, 270 0.7, 315 0. Okay, so if I join all them up now, where as I can, so you can see it is the sine graph, but it has been shifted. If I continue this sine graph on here, continue the sine graph up slightly, it's actually been shifted 45 places to the left. So I always think of it, see if it's in the bracket, it's the opposite of what you think. So it's got x add 45, but it's actually moving to the left. There's a shift to the left of 45 degrees. Okay, so the sine graph, still the same shape, it's just been moved 45 degrees to the left. What about this one down here then? So we've got y equals sine x take away 45. So again, if I put all the values of x in there where that x appears, we've got 0 take away 45, which is negative 45. Now that's not in my table of values, I'm just going to leave that out just now. This one here, we've got 45 take away 45, which is 0. So we know sine 0 from the first one is just 0. X is 90. 90 take away 45 is 45. So it's going to be 0.7. And then you can see what's happening here. 135 take away 45 is 90. So it's going to be 1. So again, I'm just going to look at this table of values from the first table of values, and just copy that down. So I started at 0, then 0.7, then 1, then 0.7, 0, negative 0.7, negative 1, negative 0.7. And if I was to plot them, so 45 along 0 on here, 90, 0.7, 90, 0.7, 135, 1, 135, 1, 180, 0.7, 180, 0.7, 225, 0, 225, 0, 270, negative 0.7, 315, negative 1, and 360, 0.7. And again, if I was to plot this, what it would look like. It would look like this here. I can continue this up. Okay, so even though it says x take away 45, it has shifted, you can see it has shifted to the right 45 degrees. So it has shifted, it's been a shift to the right of 45 degrees. So like I said before, the way I remember it, if it's in brackets, is the opposite of what you think it's going to be. And I've just plotted the table of values for you so you can see why that happens. So let's look at the next slide. Okay, so the first one is just your normal, sorry, I'm just going to change my pen back to red. There we go. This first one here, I've just drawn the sine x graph just to remind you what it looks like. And we're going to compare that normal y equals sine x to all of these and see what has happened to it. Has it been shifted? Has it been shifted to the left or to the right? And what does that mean? Okay, so let's look at this first one here. We'll look at this one here. I'm just starting. So you can see that it's a sine graph. Okay? And you can see, just highlight it. You know that it's a sine graph. Okay, so I can start by writing y equals sine x. You know the amplitude is 1 and negative 1, so I don't have to write anything from that sign. I know it's really a 1 there. But where did it start? It started at 50. Where does it normally start? It normally starts at 0. You can see that there from the original graph. That middle point there is 230. What is it normally? It's normally 180. And then that last value is 410. And what is it normally? It's normally 360. So what has happened to it? It has certainly shifted to the right. So it has moved to the right. It's been a shift to the right. And it's been shifted 50 degrees. Because 0 add 50 is obviously your 50. 180 add 50 is your 230. and 360 add 50 is your 410. So remember what that looks like. So it's going to be in your brackets, and if it's shifted to the right, is the opposite of what you think, so it's going to be take away 50 inside the bracket. Okay, let's look at the next one. So let's look at this one here. I'm just starting here. So again, it's a sine graph. You can see it's a sine curve, so you can start at y equals sine x. Now you can see the amplitude is 3, it's up to 3 and down to 3, so I'm going to put 3 at the start. We know that from previous videos. What can we see? So we can see they've got the maximum value happening here when x is 80. Where does the maximum value occur normally in y equals sine x? That usually happens when x equals 90. So it looks to me that it has been shifted. There's been a shift to the left of 10 degrees, but let's just double check that. Again, the minimum value of the sine x graph usually occurs at 270, but now in this one it's happening at 260. Yep, so it's definitely been moved to the left by 10. So what does that mean? How do we write that? So we're going to put our brackets in, and remember it's opposite to what you think you're going to write, so it's going to be x add 10. Okay, next one. So we've got this one here. So again, yep, got a sine curve. So we can start by writing y equals sine x. What else do we notice? We notice that the amplitude is 7 because it's up to 7. So it's got a maximum value of 7 and a minimum value of 7. So we're going to put that amplitude in. And notice it's been shifted. It looks to me like it's been shifted to the left. Now, what do you think it's been shifted by? So if I go back up to my original y equals sine x graph, my sine x usually starts at 0, but it's now starting, it's now starting at negative 20. So it looks to me that it's been shifted to the left by 20 degrees, but let me just double check it. My normal sine graph has usually got a period of 360. This one, you can see it only goes up to 340. So yes, it's definitely been shifted to the left by 20 degrees. So how do you write that? So in your brackets, remember the opposite to what you think it's going to do, is you're going to add 20. And that's your final answer.